Electronegativity is the ability of an atom to attract electrons to itself in chemical bonds. So we'll see that certain elements, when they bind together, will have an unequal sharing of electron density within the bond. For example, fluorine has a high electronegativity, 4.0. Hydrogen has a much lower electronegativity, 2.1. Being that fluorine is more electronegative, it will attract the electrons in this bond more than hydrogen will. And so the electrons will spend more time around the fluorine and less time around the hydrogen, so that the fluorine gets a relatively negative charge, and called a partial negative charge, and hydrogen will get a relatively positive charge, or a partial positive charge. So you'll find this in covalent bonds, but also it's applicable to ionic bonding as well. Lithium fluoride. Fluoride is so much more electronegative than lithium that we'll say that the electrons are shared so dramatically towards the fluorine or fluoride that it's no longer really a covalent bond. It's not sharing electrons, but actually is now ionic bonding. Electron density flows towards the more electronegative element, fluoride, giving it a negative charge. So electronegativity affects things like polarity and therefore the intermolecular forces like boiling point, vapor pressure, solubility, etc. But how can we know the electronegativity of certain elements? Well, you can take a look at these here. Some of the more important ones: hydrogen is 2.1, lithium is 1.0. Boron is 2.0, carbon 2.5, 3.0, 3.5, 4.0. In fact, the highest electronegativity element is fluorine, and the lowest electronegativity element is francium, 0.7. You'll want to add to your postcard that in the top right-hand corner of the periodic table are the high electronegativity elements, and in the bottom left-hand corner are the low electronegativity elements. Now, we don't include helium or neon in terms of electronegativity because electronegativity is defined as the ability to attract electrons in bonds between elements. But helium and neon are noble gases. They don't bond to anything. So helium is not the highest electronegativity, but actually fluorine is. Now, why is it that the electronegativity seems to be increasing as we go to the right? Well, it's because we have increasing effective nuclear charge. We have more and more protons attracting electrons within the bond, but the same number of inner or core electrons repelling. So having more and more protons, but the same number of repelling inner or core electrons, there's greater and greater attraction for the electrons in the bond towards the nucleus as we go to the right in the periodic table. So fluorine pulls electrons in bonds towards it more than boron does. Now, as we go down, there's a decrease in electronegativity because there's an increase in the radii of our elements. So, for example, fluorine is quite small in radius. It has electrons in the bond fairly close to the nucleus. Yet, things like iodine, they're so large that electrons in the bond are further from the nucleus. Not being as close to the nucleus, they're not as attracted to the nucleus, and therefore won't be drawn in towards that iodine. So as you see, when we went from fluorine to chlorine to bromine to iodine, as we went down, our atoms got larger and larger, and hence we got less and less attraction of electrons in the bond towards the nucleus. We had decrease in electronegativity. All right, thanks for watching, guys.